All right, welcome everybody to episode 30. I'm just making sure that everything is running. That things are running smoothly on our back end. My name is Felipe, Creative Director here at MakerBot, and yeah, I just need to confirm that the stream is running. Let's see. All good. All right. It's always kind of a hassle. We need to make sure that YouTube is getting our data correctly. Then basically that means that you guys are getting our signal correctly. But yeah, anyways, thank you guys so much for joining us this morning. Really excited to be talking about metal and carbon fiber. Because yeah, it's been a week. It's been a week since we introduced metal to the materials family, I suppose. And we'll be talking about last week we talked a little bit of, metal in general, what it is, how it works. This is kind of a double down on that, but specifically what happens when you try to interface metal with other materials. Because I think that kind of like going back to that main slide right here, right, where you see this gear and this motor, and I have that part also here in my desktop. So I have this part interfacing between, well, this assembly that actually interfaces metal with carbon fiber and with ABS. So I think that for most of you guys out there, you will not be printing just, isolated metal parts. I don't think that's kind of the purpose of this material anyways. For some applications, it might be that. But the truth is that more often than not, these will be parts that will be making up more complex assembly, right? Essentially, you're trying to use metal where metals do, where it's actually going to be useful. So I'm going to be talking about a few of my quick tips, I guess, or my experience, maybe that's a better word for it, printing with metal, and the implications of the sintering process. Because as you know, metal. I'll go to the website right now because I want to talk again about the sintering process and the printing process, right? As you know, metal, when it comes out of the method, right? The part, it's super dense, probably 80% metal. I don't really know the exact percentage, but it's not done yet. You have to send it back to the sintering facility for it to actually get sintered and come back a fully metal part, right? So essentially, it's going back to these three steps. So I'll cover them briefly for all of you guys who might have not joined last time. But essentially, you print your part and you get what we're calling a green part, right? You can print metal with, and we're talking about 316L stainless steel BASF metal with your method printer, whichever method you're using. It could be a regular method, it could be a regular X, it could be one of the carbon fiber edition, doesn't really matter. You just need to be using the labs extruder and the relevant filament, right? And once you're done, you'll get what we're calling a green part. And I have a few of them here with me. I'll be showing you how those look like in just a second. But you get a green part, and that green part is super heavy, super dense. It's pretty much your metal part. However, it needs to be sintered to remove the binding agent, right? To remove that excess plastic that allowed us to print that part successfully. And that's done using a sintering oven. That oven, it's a massive machine. It has certain requirements. And in our case, we are working with Matter Hackers to provide those services. So you actually get a ticket from Matter Hackers every time that you get two tickets, two processing tickets from Matter Hackers every time that you purchase a spool of the metal filament. And that allows you to send back in about 1 kilogram of metal parts. Doesn't really matter how many parts you're sending in. The limit is on the weight. And the other thing that you have to consider is that that sintering oven will also have specific set of dimensions, right? It has a limit on how big a part it can actually sinter. So that limit being about 100 millimeters cube, right? If you go beyond that, then simply it's not so much that you cannot print it on the method, but there's no sintering oven available for you to sinter your parts at. So yeah, there's that as well. You'll send your green parts. You'll make sure that they are sort of wrapped up properly and sent appropriately to Matter Hackers. They'll process them for you, and you'll receive back the actual, the actual stainless steel part. This takes a little of, it can take as little as 5 days. It can be a couple of weeks. It depends on the sintering window that you're grouped into, right? Depending on which day of the week they receive your parts, they'll put you in a window, basically a queue, that accumulates all of the sintering parts that they will be getting, and that's what defines the turnaround time for your part. But once you have your parts back, and this is, I think, what I wanted to talk about today. Once you have your parts back, you will have a properly metal part with you, right? So I have a few of these here. Let me disassemble this. And it's just so amazing to just feel the parts. I mean, I'll let you guys hear it for a second, but, oh, sorry, let me get in camera. I think that for me, that's been kind of the easiest way to show of how much of a metal part are we talking about. These parts have been printed with 100% infill, right? So it's 100% or close to 100% solid stainless steel parts, right? They are really heavy, really dense. And because of the sintering process, and this is what I was referring to with the green parts, the parts will scale down when they get sintered. It's very similar to what happens, I would say, with ceramics, right? If you've ever done any sort of pottery, you get your green part in an excess dimension, and that's also covered by the change. Well, it's not covered. You have to change the scale of your part to accommodate for that shrinkage. The shrinkage is about 20% in X and Y, like even, so 20 in X, 20 in Y, and about 26% in Z. So it's an uneven shrinkage. That's due to the way that the material will perform in the sintering oven. But the point being here that once your part gets run through the sintering machine, so this is the actual part that we sent, well, it's not the actual one, but this is the part that we printed in order to get this resulting part from Matter Hackers, right? So you can see there's a noticeable change in size. It's going to change more in X than in Y. So I have my trusted caliper here for you guys to see how much we actually change the size of those parts. And it seems to be, at least from my experience, right? It's fairly even. So my original dimension here was about 12, hoping that you guys can see it, 12 millimeters. And that equated to about 10, oh, sorry, it's running low on battery. Let's reset 0 here. So original dimension here, 12.4, resulting dimension 9.8. The spec here was actually 10 millimeters flat, right? So it is to some extent difficult to control, but you have a margin of error, right? We're talking about 26%, well, 20, and 26%, depending on the axis that you're referring to. But that's where it's really important to wait for your parts to come back before you sort of think about finalizing your assembly. Why? Because essentially there might be a little bit of an extra process involved later on when you get your metal parts back and you need to resize any additional elements. Because as you know, like the tolerances and method are really, really tight, right? So it's going to actually deliver parts that fit your specs up to, I think it's like 20 microns based on 100 millimeter travels, 20 microns per 10 millimeters travel, right? So that's really, 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 really tight. However, with the unevenness of the sintering process, that might be too tight for your parts, right? So in this case, I'm not even sure I can actually take this part out anymore. I printed out a sleeve, carbon fiber sleeve for my planetary gears, right? So my main gear, my outside ring of the gear is printed on metal, right? The internal planet gears, those are printed in ABS, and the external sleeve is printed out in carbon fiber. The reason why I mixed the materials was just kind of like to get a sense of how that would work, like whether it would work or not, and how does these materials interface between themselves. And as you can see here, like now talking about cylindricity changes in my part, right? So you'll be able to see here, if I zoom in, let's hope that the camera will focus on my part here. I don't know if you can see like a slight shadow between my metal part and my carbon fiber part. The reason for that shadow is an uneven shrinkage in my metal part, right? So here, this might be a little bit more obvious, actually. There's a little bit of a bigger gap there. So it's a slight gap. It's barely even half a millimeter, I would say, right? But it's there, and it's definitely something that you will have to accommodate for, either through your tolerances or through measuring your part once you get it back from the sintering process. So again, even here, considering this part itself, right? The radius in, let's call this the x-axis, it's 58.8. Just rotating it 90 degrees, seeing how tight that radius is. Here it's 59.2, right? So you can see there's definitely a change that's occurred. And that change, just to sort of to double down on where does it come from, I will measure this part, which is one of my green parts. It's not the exact same part or the sort of precedent green part from this gear, but you'll see, and I'm expecting because I actually haven't measured it, but you'll see how the actual part that you get out of method, it's really tight up onto those specs, right? But when you get the sintering process added onto the part, that uneven shrinkage will definitely affect the specs, the dimensions on your part. So let's see what happens here in my green part. So my green part here, 80.9, I would say, 90 degrees. 80.9, right? So this part is essentially like 100% a circle, right? There's no real deviation in any one of the axes. Whereas this metal part, the one that's been sintered, has changed a bit, right? It's not a lot. It's not. We're not talking about 5 millimeters. We're not talking about, you know, half an inch here. But it definitely will change your part, even when you're talking about fairly even parts like this one, which is essentially just a hollowed out circle, right? You'd expect kind of it to behave a little bit more constant if it was a more even geometry. It's not, right? So there's multiple ways to accommodate for that. My recommendation here would be just to get your parts back first, remeasure them, and based on that, make any relevant adjustments in your CAD. You could always also just have larger margins in your part. So in this case, what I did here was I added about 0.5 millimeter of margin in my external sleeve, and that was enough to accommodate for any sort of shrinkage or deviation of my metal part. By the way, if you have any questions, there's a comment box to the right, and Alejandra is capturing all of the questions that you might have relevant to metal printing and interfacing with other materials. And that's also true for the planet gears here inside, right? So I'm actually finishing up my system, my proper driving system here. And as you can see, you know, I also had to make some changes for my planets. Let's see if I can put it. I would rather just run it with the motor, but I don't have my stepper motor available right now, so I'll just run it manually, right? So I did have to sort of double measure my internal planet gears just to make sure that they would interface correctly with my external metal gear because of that same issue, right? Those small variations, they will affect how your parts interface with one another. Having said that, though, you can always post-process these parts, these metal parts now, in any, you know, sort of conventional metallic post-processing tool, right? You can either sand them, or you can cut them, or you can, route them probably. I haven't tried it though. I'll say that up front. But definitely, you know, these are metal parts, right? So this is going to actually behave in a very similar way to a solid metal part. It's still going to have some of that anisotropic behavior based on the fact that it's a 3D printed part, so it's a layered part, but it's solid, right? So it's very close to just a completely solid part. So you could either, you know, that's another way to accommodate for those deviations. It's going to be just to post-process the metal part itself as opposed to the excess part. And what I wanted to show you with these guys here, so these, the way that this part was printed, right? The idea here was for this line to completely follow up with my sort of initial gripper element here. So this should be a straight line, and therefore this should be also a straight line. But you can see how there's a little bit of a gap happening here. If I position my part so that that gap disappears, right? So all the way up against that wall, what happens is that now there's a little bit of an excess amount of material protruding here from the lower end of my what I'm calling my claw, right? It's going to have a little bit of wiggle room. So if I make it fit on this plane, it's going to separate a little bit from this plane. And that's, again, it goes back to that same idea of you will be much better off by sending a part, taking it back, and then making sure that you remeasure it just to make sure that you've covered all of your bases on any sort of excess margins that you might need for the part to interface correctly. It's not a lot, right? It's definitely not deforming the part. Like, it's even what I really like about this one specifically, just how much the process has actually respected my texture, right? So you can see how textured the original part was, and that texture is essentially the same, even though it was completely scaled down, right, by the process itself. I'm hoping that this will sort of focus appropriately in just a second. But even though it was scaled noticeably, it's I mean, 20% scaling down, it's a lot. But that texture is still there, right? All of the diamonds are completely visible. That sort of fading in the texture is also there. So I actually made this in Grasshopper, and you can see how the center diamonds are a little bit protrude much less than the outer diamonds here, right? And that texture is present in both elements. None of the diamonds were damaged, right? They also are fairly straightforward geometries. They don't require any supports. They don't require any sort of special treatment. So again, the part is going to change, but that doesn't, I think for me, right, it doesn't really limit the possibilities with the parts. It just adds a little bit more complexity to the process. It's not straightforward. You have to add that sintering process, but just like anything, right, it's just like any sort of post-processing process, it's going to require some level of knowledge to actually work with it and know precisely what you're doing. So I'll start looking at some of the questions that you guys might have in the comment section. Alejandra, thank you for collecting those in the back end. So is it possible to join carbon and metal parts in a cost-effective way? Well, yeah, that's, I think, one of the cool things about this, right? The point here with the metal printing in Method is that you're getting a machine, and this is a machine that I got behind me, right? Method is a machine that now can print carbon fiber, metal, ABS, composites, a range of materials in the same machine. That's kind of like the beauty of it. It's a machine that doesn't limit you, right? We know that there's many machines that are sort of bespoke for metal printing, or bespoke for carbon fiber printing, or bespoke for ABS printing. This machine, I'm biased, but it sort of does it all, right? It's actually covering a wide range, and that's what this assembly shows, right? This is ABS, metal, and carbon fiber, all printed in the same machine. And that's what makes it cost effective, right? It's a freaking beast of a machine in quite a, I would say, a really interesting package. Also, by the way, we'll be having a webinar later this week on Thursday, I believe. We'll post a link in the description of this video. So if you're interested in attending that webinar, today is February 24th. This is going to happen on February 26th. So follow that link, and on that webinar, we will be doing an even deeper review of metal and how to print with it. How does carbon fiber composites resist corrosion? How does carbon fiber, well, it's essentially, that's due to the fact that carbon fiber will not rust, right? It's a mix of a polymer and a composite, so neither of them should actually corrode in any way. There's no, if you're talking about like chemical corrosion, that's due mainly to the nylon, right? Nylon is going to be a much more stable material than other polymers when exposed to certain chemicals. So maybe that's what you're referring to, but it's mainly due to the mix of, it's not pure carbon fiber, but it's nylon 12 carbon fiber, right? That's a composite that we're using here. We also have nylon 6. I would 100% recommend nylon 12. There's a few webinars and chats on that, but that's definitely a different subject. What is the best resin to use with carbon fiber? We are not using any specific resin. So with carbon fiber, when you're doing layered carbon fiber, right? When you're actually using sort of cloth carbon fiber, you will be using a resin. With Method, you're not dunking your parts in resin once they're done, right? The part itself is already done when it comes out of the machine when you're using carbon fiber. So it doesn't really affect, you don't need any additional resin or post-processing element when using nylon 12 carbon fiber on the Method printers. What is the workflow that I can expect when working with metal filament? Okay, this is a good question. So I would describe it as 3 main steps, right? First off, you will be printing your part, your metal part, using the labs extruder and your metal filament in the method, right? We have already the settings available for you in Cloud Print and in MakerBot Print. You will be getting what we're calling a green part, so it's kind of like doing a quick review of what we covered so far. You'll get a green part. Once you get your green part, you will send that part back to Matter Hackers. They will provide you with a sheet that basically says, you know, what are you sending, what's the weight of the parts that you're sending, how many parts are you sending. There's a limit, a weight limit of 1 kilo per processing sheet. And then in about a week or so, you will be getting your final finished parts after they've been sintered, right? So you will be getting back the parts that you sent out. That's essentially it. I mean, we've been seeing a lot of comments on social media, right? That's like, it's not that easy. And for me, it's been that easy, right? It's just you print it, you send it, you get back your metal parts. There's a few considerations, of course. You should not use supports, or if you're using supports, those supports should be manually created as opposed to just letting the slicing platform create the supports for you. The reason for that being that any sort of supports that get sent back to the sintering processing factory will become solid metals, right? So anything that you send out will come back as solid metals, and removing solid metal, as you can imagine, it's going to be kind of a hassle. So you need to not use supports. There's a limit on the size of the parts that you can send, so of about 100 by 100 by 100 millimeters. And you probably should use some sort of build plate adhesive stick. I'm using Dimefix here. But yeah, we can talk about that too. What guidelines should I keep in mind for metal parts? I think I was covering those, right? So the parts should be about 100 by 100 millimeters tops, right? Anything smaller is going to be better. They should be what they're calling like laid up on the side, right? So having a larger side where they can rest on will result in more successful prints, right? So anything that's kind of pancake shape, to call it something, will be better or more successful at sintering. And other than that, no supports. So it reminds me a lot of like my first days using a 3D printer in general, right? Where it's like, the simpler the geometry, and that does not need to be plain, right? We're not talking about printing cubes here. But the more straightforward geometries, the better it'll be, the easier it'll be for the sintering to be successful. And that doesn't mean, as you can see here, with I'll bring back my textured elements here. That's not, simple parts doesn't equate to straightforward or flat parts. They can have quite a lot of detail, but it's I guess that the main element that you want to keep in mind is how much supports are you using, how self-supporting the part is. Like even in this sort of two-way pipe, you can see how, since it's a self-supporting geometry, then there's really not much of an issue, right, when printing and sintering. Does the green part already have some mechanical strength? That's a good question, and it's something that we keep getting a lot. I would not use the green part as is, because it's hard to convey it, but it's definitely strong, right? So I don't think I would be able to break it with my hands, but it does feel like raw clay, or almost solid clay. It's hard to describe it, but it has some strength. I would not use it. You need to run it through the sintering process for it to actually behave like a metal part and to become essentially a metal part. What are some common applications for these materials? Well, I would say it depends on high wear parts, right? So metal for high wear elements, carbon fiber for elements that need to be lightweight but really strong. So for example, what happens here in this gripper, and that's what I like about this example, right? We're only using metal where metal is needed, because just these two parts, these two elements, weigh as much as this whole assembly, right? Actually, just one element weighs as much as the whole assembly, because the assembly being printed out in carbon fiber is going to be way lighter than just this one part. So essentially what we're giving you is the option to focus the metal part, the metal material where it's needed, on the elements that will have to interface with either a more aggressive component or will have to have added strength to them, and keep the lightweight elements like carbon fiber in everything else, but doing that in the same machine. So with that, I'm going to wrap it up. I was looking at the the webcam here. But with that, I'm going to wrap it up. As always, thank you guys so much for watching. Let us know if you have any questions. And don't forget, we are actually having a webinar, so follow that link in the description if you want to learn more about metal. It's happening this Thursday. So if it's past this Thursday, which would be the 26th of February, then you can look it up under our resources section in MakerBot. But if you have any questions, do send them out through either Instagram @MakerBot or Twitter, same handle. And yeah, thank you guys so much for coming, and we'll talk to you next time. Have a good one.